And welcome back as we go ahead and continue our discussion on wrapper classes. Recall previously we had talked about wrapper classes, and so now let's go ahead and deepen the discussion by discussing some of those methods that are available to us. So with wrapper classes, we previously talked about why we call them that, because it allows us to box and unbox primitive types. However, they're not simply just limited to that. They also contain several use of constants and static methods that we can use to make our code much more powerful. Now, wrapper classes have two distinct personalities. The first is their ability to produce class objects corresponding to values of a primitive type. The second thing, though, is also to serve as a repository of useful constants and methods. Now, while it's not necessary to combine both of these two properties into one class, the developers of Java chose to do that so you'd only have one set of classes that you have to manage for both personalities. So let's discuss, for example, largest and smallest values. So this is one of the things that we can use wrapper class for. So let's say we have the associated wrapper class to find the value of the largest and smallest values of any of the primitive number types. So for example, the largest and smallest values of type integer are integer.maxValue and integer.minValue. If we want to do the same thing with doubles, we can say double.maxValue and double.minValue. And of course, we could, for example, put those in a print line statement. We could find out what those values are. But what we're going to probably use these more for are things like parsing. This is going to be a very common thing. So let's start first by discussing parse double. Wrapper classes have several static methods that can be used to convert back and forth between string representations of numbers and the corresponding number of type int, double, long, or float. The static method parse double of the wrapper class double converts a string to a value of type double. So for example, if we have the code double.parseDouble, quote, 199.98, end quote, so that's a string, would return the double value, 199.98. Of course, if we wanted to actually store it in a variable and actually use it in our program, we'd have to do that as well. Now, what about this in a string? How about we, of course, this was just as a parameter. Let's actually see this in a string. So again, we often deal with parsing when we're working with strings because we need to get particular values out of there. If there's any possibility that a string has, for example, extra leading or trailing blanks, we should always add in just, for example, if we have a string called the string, we can say double.parseDouble, the string.trim, and that would, of course, remove some of those spaces that might be in there. If you recall, the method trim is a method of the class string that trims off leading and trailing white spaces such as blanks. If the string is not a correctly formed numeral, then our invocation of double.parseDouble would cause our program to end. And the use of trim is actually a way for us to kind of help somewhat avoid this issue. Now, you don't have to put trim in there, but it can be a way to kind of help avoid those potential issues. Now, of course, there are other parse methods that we can use. Similar to parse double, we have static methods for integer, we have long, we have float, and you notice it's all parse and then the name of it. And these convert from a string representation to the numbers of the corresponding primitive types of int, long, and double, or int, long, and float, respectively. Now, each of the numeric wrapper classes also has a static method called toString, which converts in the other direction. So if I want to take and put it into a string from a numeric value with a string representation, I could do that. So for example, I say double.toString 123.99, I would get the string value, quote, 123.99. Now, there's a little bit different things when we start dealing with characters and booleans in comparison to our numeric types. For the character class, the wrapper classes are for the primitive type char. These contain several static methods that are useful when we deal with things like string processing. And of course, we also have the boolean class, which corresponds to the primitive type boolean. And the thing about boolean, it also has two constants that we can use to our advantage. So we have boolean.true and boolean.false, which are the boolean options corresponding to the values of true and false for the primitive type boolean. Now, there is a pitfall we have to address here with wrapper classes, in that they do not have no-R constructors. This is something a little bit maybe unusual to think of because these are pre-existing classes in Java, but they don't have these no-R constructors that we previously have talked about. Now, normally when we're dealing with classes, it's a good programming practice, for example, to define a no-R constructor in any class we define. However, on rare occasions, no-R constructor simply doesn't make sense. It doesn't make sense to have something that doesn't take in a value. Now, the wrapper classes don't have no-R constructors. And because if you think about it, when I say like integer num equals 42, notice we don't have to say like new integer, open close parentheses, all that stuff. Instead, if we want to just add methods in class, we don't need a calling object, and we don't need a constructor at all. In fact, we can just define it, and off it goes. Because remember, the other function of wrapper class is to provide a class object corresponding to a value of primitive type. So if I say like new integer 42, this is going to create an object of the class integer that corresponds to the value 42. However, again, we don't need to worry about this because of how the classes are set up. And also remember that because of how Java has updated, where with the declaration of integer is deprecated in this half, so we don't have to say new integer 42, we can just say equals 42. These are things that we have to keep in mind as a programmer when we start looking at our code. And speaking of code, let's pop over into Eclipse and take a look at a couple examples. Now, the first half of this program, I left some errors in here on purpose so we can have some discussion about some of this stuff with parsing. Because even though, yes, we have access to all these different methods, it's very easy to pull them up. So, for example, I'm just going to come down real quick here. If I want to see some of those methods, if I just were to create a quick variable here, let me just set this to a number type here. And, I think it's complaining because I have something called anum here, so let's just make it a number. There we go. That should resolve that. And we're complaining because we need to make this a double type, so let's just make that 5.0. That should solve that. There we go. So little thing to keep in mind there if you're trying to put in whole number values. But I want to show this because if we were to say a number and I were to hit dot, I can of course get a list of all these different methods that are available to me that I can start using for this wrapper class. Same thing goes for float, integer, whatever. So keep that in mind as we start looking at this. But the one thing I really want to hone in is on parsing, because parsing is going to be something that we're going to probably end up using a lot in our programming career, is taking a string and wanting to find particular values, particularly let's say numeric values that exist within it. So here I have a quick print line statement that says converting the string value to an int. And my string value of a num is 99. Now, we know that this doesn't work. I can't say int num equals a num. All right. And why is that? Well, because this is an integer type. This is a string type. We know that from our beginning of programming that we can't do that. So this does not work here. I'll just say does not work, okay? So we cannot have this work here, again, because one is a primitive type, one is a class type, and we can't actually convert those. Now, if I say integer number equals a num, well, this is a class type. Why doesn't it work though? Well, that's because even though this is set up with a class type, these are not the same class. So because it's not the same class, we have to do some conversion between them. If you think about how we've done this with primitive types, we had to do some type coercion. So for example, when I did division and I want to get a decimal answer and I have, let's say, two integers and I say, let's say 5 divided by 4, well, I'm not going to get a double value unless I, of course, have some type of typecast in parentheses for double. However, we aren't going to just put in here, like, for example, integer and get the expected value, because that doesn't work. I do want to have what type I want to use, which in this case is integer. So I'm going to say integer. But instead of putting it in parentheses, I'm going to use my methods that I have available to me. So I'm going to go ahead and hit that dot there. And I'm going to go ahead and try to get the value. Now you can see we do have some other methods here. For example, we have like get integer, which says it's going to decode a string into an integer. But the one we're going to probably use here is actually parse. Because this, if you look at these return types here, that does come back as integer. But we're going to use the parse one because this is going to be the one we're probably more interested in. So we have parse int, which is of course the one we want to process. And if I save that, you'll see all my errors go away. So it's saying, using the integer class, I want to parse or break this string down into a type I'm looking for. In this case, that type is int, so parse int. And what string do I want to process? Well, I want to process a num. And so then I can put in my print line statement number, and I should expect to see 99. Now, we can also, of course, use this in some deeper context here. So in here, I said finding the hidden 0. So if I have a string called hidden num, I have hidden 0. Notice 0 is not a numeric value here. It's a string value. But it's also got other things kind of hidden in here. So there's some other strings and stuff like that. So I need to find where that 0 exists. And since I know it is explicitly this number, I can look for that character. So what I did is I said, hey, I'm going to create an integer that's going to find the index of it in that string. So it's a where in this string, hidden num, is 0 at. And that's going to give me a number value. Now, that's cool, but this is not going to give me, of course, what that value is. Now, if this was, let's say I didn't know what this number was, it would take a little bit more work to do this, but just for our demonstration purposes of what this parsing is doing, I want to just have something simple. And then what we can do is say, hey, since I now know this, I can actually just take this string and create a substring with just this 0 in it. Now, if we had other things that came after 0, we'd have to, of course, determine where that ends. Or if we had, like, for example, white spacing that we had to deal with, we, of course, would have to handle that accordingly. But again, simple example here, just so you can kind of get the idea. Then once I have this, because this at this point is simply going to be the 0 in here. Because remember, we trimmed this off because we took a substring, chopped all this first part out of here. So everything that was hidden in the space, I removed when I made the new substring. So now when I parse this, I should get the hidden num, which should be 0. So we should expect when we run this program to get 99 for this first print line statement and 0 for the second one. So let's go ahead and give that a quick run. And so we have converting the string value to an int, which was 99, and we get 99, so that's great. Finding the hidden 0, which of course in here it says hidden 0. And if you look, it printed out find num, which of course was that 0. This might seem a little overwhelming, a little complicated, but this is something that's very important for us to get a good handle on. If you're not understanding it, just take some time, do a couple practices with this, get used to taking a string, being able to break it apart into different pieces, doing things like substrings, char at, index of. These are going to be great methods that we can use to help start taking these strings and breaking them apart into their different components.